do a recount.
Yeah, I think a recount.
Look at you guys.
Joe, haven't you heard this enough?
I want to see the reaction.
He's like, what?
Is Michael?
He's not easy.
All right, we'll get started. Thank you everyone for coming to the last energy symposium of the spring 18 semester. So for those of you in the class, the reminder, the research note, the second research note is due next week, so make sure to get that in. Today we have three people involved in the Planet Texas 2050 UT Austin Grand Challenge going to speak with us. So if you didn't think Texas was its own country, now they're telling us it's an entire planet. So I'm surely that'll be probably the second slide on that. But so I'll just give a brief introduction of who's speaking with us today. So we have Dr. Jay Banner, is the Bullard Professor of Geological Sciences here at UT Austin, Director of the Environmental Science Institute, does a tremendous amount of work on science engagement in general and throughout the state, perhaps notably through the Hot Science Cool Talks series that goes on occasionally throughout the year. How many have there been? There's been
Tomorrow night is number 113.
Okay, we'll have number 113 tomorrow night, the 113th. So that's a tremendous undertaking, and especially for it to go that long is a tremendous accolade to him and that program. We also have Heather Hauser, Associate Professor in the Department of English. So we'll have some perspectives on how do we, communication of science. So she studies science, technology, and culture, environmental literature and criticism. So maybe we'll hear what that is. And to give the perspective of how we communicate issues regarding the environment and society in the context of this project. And the third person speaking with us today is Rich Corsi, the Professor of Civil Architectural and Environmental Engineering, also co-director of Center for Sustainable Development. And I know he does a lot of work on building environments, air quality in building environments, so all kinds of interesting studies on the trade-offs of managing building environments and energy efficiency and these kinds of ideas. So I will now step down to let them start talking. So who's first? All right, so we have Jay Banner first. Take it away, Jay. Thank you very much.
All right, thank you, Kerry. You could hear me all okay? Great, thank you. Appreciate the invite to be here. It was, I think, 3 years ago I was last invited to come talk about my research. It's nice to talk about this new research initiative today. And in short, basically the short story is that Texas is a climatological hotspot. It's a demographic hotspot. And this poses some really unique and synergistic challenges for how Texas is going to find its way through the 21st century in a way that makes our state resilient. And so we need this resilience in order to take on these challenges, these very synergistic challenges. And this research initiative is about how can we do research to actually observe, collect, analyze, model, and project forward to see, and also project backwards to see how Texas can achieve resiliency and come to what my co-speaker Rich Corsi likes to say, a soft landing by 2050. So it'll be myself, it'll be Rich and Heather. Michael is ill today at the last minute, so we're going to be filling in for him. Any slide where it looks like, we're not that sure what we're talking about. We're talking about Michael's slides. So. All right. So the brief history of this initiative, it's part of the larger Bridging Barriers initiative that President Fenves unveiled in his 2016 State of the University address. What he says here is, well, you could read it, but the key thing here is crossing boundaries, and that we really need a very inherently interdisciplinary approach to address them. And breakthroughs happen when we break through these silos of knowledge, and that's what this is about. So basically the Bridging Barriers is addressing an important societal problem and doing it in a very interdisciplinary way. And I think you'll see when we talk about the team, or the theme organizing committee, as we call ourselves, there's 8 of us, and I think we're from 8 very, very disparate disciplines. Well, so then at the end of 2016, there was a call for concept papers by the Vice President for Research Office. They expected a couple of dozen. They got 135 of these concept papers by more than 800 authors. Authors who authored similar concept papers were introduced to each other and said maybe you could work together on these things that are seemingly overlapping. And that's when this Planet Texas team formed, and we put together a larger proposal that went forward. And that was that call for full proposals in the spring of 2017. And by the end of the summer, Planet Texas 2050 was chosen as the first of these bridging barriers initiatives to go forward. All right, then it was December of that year that we had an external review of our long research plan. So we had experts come in from other universities around the country to give us feedback. And then it was January 17th, that should say 2018, officially launched was Planet Texas 2050. So we haven't been going very much so far, just several months. And we're going to sort of give you now an overview of what this is about, given this history. All right, so this will set the stage here a little bit. This is, if I asked you to close your eyes and imagine what North America looks like from space. If you're on a satellite on the space shuttle, you probably conjure up something like this. And what you'd see is, right here is where we are. X marks the spot. There's the Balcones Escarpment. There's the Colorado River. And you can see that Austin looks like it's separating, being right on the boundary between the humid, lush southeastern U.S. and the arid vegetation not doing so well southwest U.S. And actually, it's been proposed that this line, the 100th degree west longitude line, also known as the 100th meridian, is demarcating the humid southeast from the arid southwest. This was first proposed in the 1800s by John Wesley Powell. And our take on this is that we are looking potentially at a new 100th meridian, a new position for it. The line of longitude won't shift. It's actually going to be where that wet-dry boundary, that's what makes it a climatological hotspot, right on the border between the humid and arid. This transition zone is very sensitive to changes in climate. And I'll basically posit that the best available climate projection information is that wet-dry boundary will shift to the east, as it has done this century. In 2011, there was a historically intense drought. In the 1950s, there was a drought of record that the state uses for all its water planning. If you go back in we call the proxy record to look at tree rings and whatnot, you'll see that there are times in the past when there were mega droughts in the southwest U.S., droughts that lasted 10, 20, 30 years, including one that brought to an end, archaeologists believe, the Anasazi civilization in the Four Corners region of the southwest U.S. Okay, so this is what makes this a climatological hotspot. It's very sensitive to these changes. We'll look at that a little bit more, and we'll also explore why it's a demographic hotspot. So here's the U.S. Drought Monitor. This is this 2011 drought I was telling you about. If you look at the warmer colors are more intense levels of drought. I'm convinced if I keep shaking this, it's going to show green there. And so you can see the warmer the colors, the more intense the drought. We go dry, moderate, severe, extreme, exceptional. The climate model suggests we have to come up with a new adjective for D5 and D6 that we're going to see potentially later this century. So what would you come up with that went beyond? What's beyond that? Sorry? Horrific. Epic? Epic, that reminds me of like legendary, maybe, or ultimate. Super duper. Okay. Well, it won't be so super, right? Or duper, right? But all facetiousness aside, the concept is, if this is the position of that 100th meridian right here, we could see that in 2011 there was a shifting of that boundary significantly to the east. It didn't last very long, but the projections are that will become a more permanent shift. And so that's going to have a big impact on water availability. And now let's bring in the demographic part of this. So here's projected population changes from 2010 to 2050. And you can see all of these warmer colors again are, what cities there are right in here. The percent change greater than 100% in these darkest brown colors. So a doubling of the population in a lot of these places. The entire state, we'll look at that in a minute too. So this is projected forward, but if we also look at the breakdown between urban and rural from going back to the 1850 to up to 2010, what we see is that the rural, shown in blue here, has been relatively steady, whereas the population on the urban side has been dramatically increasing, right? And the demographers actually project that this trend will continue forward. In other words, all of these new people, twice as many people in Texas by 2050, 2055, almost all of those people will be moving into cities. Right? And so putting this together, we could see, again, looking at the present day 100th meridian, which is a pretty good approximation for the humid, arid boundary, we see lying in wait for it are all these counties with greater than 75% population growth by mid-century, from Rio Grande Valley, San Antonio, San Marcos, the fastest growing city in the country, of course, Austin and Dallas-Fort Worth, right? If this shifts to the east in a more permanent way, we're going to have this juxtaposition of much lower water availability and much higher demand for water. And the population growth from 2010 to 2050, well, you can see, again, pretty close to doubling by mid-century. Not only will there be droughts, there is also extremes in the hydrologic cycle, which are a basic consequence of climate science, of the basic physics of climate science. When the atmosphere warms, we have these consequences. We have increased droughts, we have increased floods in areas that are already prone to these extremes in the hydrologic cycle, right? Hard in our rearview mirror, we know all too well what happened with Hurricane Harvey. It was a series of sort of cascading impacts on our infrastructure and our inability to be resilient with our infrastructure, whether it was the flooding in downtown Houston that we're all really familiar with, or living here in Austin, right? All it took was another week before there was a panic and a run on gasoline. And so here's a really good example of a series of cascading related failures. It's also a really good example of the nexus between the water and energy sectors that we'll get into a little bit more. And so the challenges for Texas in 2050, we've been through these twin drivers or stressors, as we call them. There's climate change, there's population growth. And if we put those two together, we're making a synergistic set of challenges for these sectors or pillars, as we call them. And there's four main ones, and we'll go through these in a little bit more detail. Suffice it to say for now, it's urbanization, energy, water, ecosystem services. And these gray arrows that go between all of these sectors indicate that they're all related by processes and feedbacks in those processes that link them. Right? One really good example, I'm sure this group knows, is that nexus between energy and water. Right? It's hard to clean water, pump it to our homes without using a lot of energy. It's almost impossible to make almost any form of energy without using a lot of water. So we know that already. What is the nature of those interactions in a rapidly urbanizing environment? And then how, if water availability changes, if temperatures go up so that we need a higher demand of energy, et cetera, there's going to be a series of cascading synergistic impacts between those sectors. And then all of these impacts will actually, in turn, have impacts on our quality of life, from economy to food security, social equity, and just general well-being. So these challenges are complex, they're vital to our way of life, and they're not going away. And addressing them requires a very interdisciplinary approach, as you can imagine, all those disciplines. There's the whole university set of disciplines going from here to here to here. And we're going to need new approaches to understanding these processes and their feedbacks, how we can project forward, and how we can plan. So this is sort of a bit of a master diagram we use for talking about this program. It doesn't nearly begin to get at all the levels of complexity, but it's one way of organizing our thoughts about it. And so our approach to these challenges to our state's resilience is, as I just mentioned, we need innovations in how we're going to monitor the environment and understand these processes and feedbacks, for example, between water, natural water resources and urbanization. Just two of those sectors on that previous diagram we looked at. We need to be able to integrate this new understanding of these processes into new and advanced models in order to project out future scenarios. And a big piece of this is also being able to communicate with stakeholders, decision makers, through education, humanities, and arts, with the ultimate goal of developing strategies for resilience. Wow, so that's a pretty tall order. Going to be hard to do, but too important to not take it on. So I'm going to turn this over to Rich Corsi now, and he'll take it from here, whichever one of these. Your thumb will really hurt from trying to make that thing green.
Let me fire up my bow tie. Is that working?
Yeah.
All right, good. So I think everybody can appreciate that the problems we're addressing, the problems that face Texas for the next 32 years till 2050, are not problems that can simply be solved by understanding physical science and through technology. That to move the ball is going to take policy changes, is going to take communication and education of the public. There's a lot of social science that goes into what we're doing as well. And if we neglect that, if we neglect the people-oriented parts of solving problems, we're not going to solve problems at all. And so when this team was put together, the team that was assembled is a very, very interdisciplinary team. Jay and I and Heather are here, and you're going to hear from Heather in just a moment, but Catherine Liebernick is the chair of the theme organizing committee for Planet Texas 2050. She's in community and regional planning in the School of Architecture. Adam Rabinowitz, Adam actually studies past societies and how past societies have dealt with major environmental issues, the kinds of issues that we are dealing with in a modern society that past societies have had to deal with. Lourdes Rodriguez is in the Dell Medical School, and she deals with population health, community health, which is a really important part of Planet Texas 2050. As we move forward, just population growth in and of itself is a grand challenge. If we're looking at almost a doubling of the population in Texas by 2050, and we need to make sure that healthcare keeps pace with population growth as we urbanize cities. And you superimpose that on all the health effects associated with perturbations in climate, and we have big issues with healthcare. Suzanne Pierce is with TAC, the Texas Advanced Computing Center, and she's helping with a lot of the sort of data platform and large-scale computational modeling. And I think many of you know Michael Young at the Bureau of Economic Geology. As Jay said, we're all playing parts of Michael tonight. He's ill tonight. So we are going to be rolling out the first projects for Planet Texas 2050 in this summer. They're not official yet, but there are over 50 faculty members at the university that comprise teams that make up the first 6 or 7 projects that will be rolled out. Our hope is that over the course of this entire effort, hopefully a decadal effort, that there'll be a lot more involved. Our goal was originally 150 faculty members and a lot more graduate students than that involved in the Planet Texas 2050 initiative. So urbanization is one of the major pillars of Planet Texas 2050. I think, as I said, this is a grand challenge in and of itself. Jay mentioned that most of the growth in the future will be in existing urban areas. That's true. The projections for cities like Austin is that by 2050 we may triple in population. Imagine with the drought we just came out of in what, 2015?
2011?
Yeah. Imagine if we had triple the population when we just had that drought. I'm not sure Austin would have survived. We might have had evacuations from Austin. Certainly would have hurt the economy. Certainly our city would have been a different place with 3 million people during that drought. So we have to deal with growth in urban areas, which means stresses on infrastructure, stresses on all forms of infrastructure, transportation and mobility. And this is obviously a big issue. There are ways to try to do transportation right when cities grow. I think most people that have lived in Austin for a while might conclude that maybe we haven't done it right. And imagine tripling the population of Austin right now without making major changes in how we do transportation. As we urbanize, we tend to bring people in much closer proximity to transportation-related air pollution. 11% of Americans today live within 100 meters of a freeway. We're becoming a freeway nation, right? And that number is going up every single year. And there are loads of studies that have come out in the last 5 years that link living near major interstates, major highways, major roadways with a whole bevy of health problems. And those health problems cross socioeconomic boundaries, right? So it doesn't matter how wealthy you are, how unwealthy you are, how poor you are. Increased mortality, increased stroke, increased heart attacks, increased asthma, increases in dementia. And there's great research in the Harvard School of Public Health right now that shows transportation-related air pollution going right through the nose, through a membrane directly in your brain, and concentration of transportation-related particles that accumulate in your brain and cause dementia. Autism is another area of research right now. So as we urbanize, as we bring people closer to transportation sources, we're going to have those increased health problems in Texas. Population health, as Jay already alluded to. Questions about green space and barriers and how we affect building codes for people that are living close to major highways and interstates. Perhaps, especially for things like public schools that are within 100 meters of interstates, and there's a lot in the state of Texas. We should be doing something like a massive fresh air flush in the morning before the morning commute. Before the morning commute starts, then seal the outdoor air intakes until the morning commute's over, and then open them back up and start ventilating again to protect children from transportation-related air pollution. Affordability is a big issue as cities densify. People can't afford living downtown, so they move out. Austin's a great example. We have more transportation problems. Certainly there are social and environmental justice issues, and we see that in Austin with people that are having to move out of the urban core because things have become too expensive. And then extreme events. So we talk a lot about droughts and floods. We don't talk a lot about heat waves. We don't talk a lot about wildfires. If you look at maps or projections of wildfires in the United States in the future, Central Texas is ground zero. I mean, Central Texas is projected to be the new California. So with that comes property burning down, really toxic air pollution, et cetera. So we have to deal with these kinds of extreme events. This is Santa Rosa, California, really close to my sister's house after one of the big neighborhoods burned down there. And, we don't want that to be the future of Texas, right? That's what Planet Texas 2050 is all about. How do we stop that? You know a lot more about energy than I do, so this is sort of filling in for Michael's slide. But certainly, if we have double the population roughly by 2050, where are we going to get all the energy? What's the mix of the sources of energy? Where are the demands going to be? We have a pretty good idea of where the demand's going to be. If we double in population, is it sufficient to just say we have to double the amount of energy we produce? We double the amount of electricity? What's the water footprint by source in the future? And the nature of the sources is going to have a big impact on what the water footprint is for the energy that's produced in Texas in the future. What kinds of residuals are produced? Transmission and storage systems. We can't move forward, in my opinion, thinking that we can just generate twice as much energy to deal with problems, right? We have to find ways of reducing our energy consumption per capita. When you look at where energy is consumed, we're going to have to dramatically reduce energy use in buildings. I'm a building scientist. I know that whenever we've tried to do that in the past, we've made people sick. Whether it was urea formaldehyde foam insulation back in the early 1980s that made a lot of people sick in the name of trying to conserve energy. Weatherization, and if you read the literature in indoor air quality, weatherization programs tend to make people sicker. Is for all the good they do, right? And there's a lot of other examples I could give you of trying to do the right thing to conserve energy makes people unhealthy. It affects people, all right? So we need to find ways of conserving energy in buildings and also not reducing the health of Texans. Dealing with extreme events as we see more heat waves in the future, how is that going to affect energy availability, brownouts and that type of thing? And then affordability and access where we have economic justice issues there. This was definitely Michael's slide. So ecosystem services we're broadly defining as sort of our interaction with the natural environment and things that we glean or get from the natural environment, and how those interactions will be affected in the future as cities grow into the natural environment. So sort of the interface of cities and the natural environment. Benefits humans derive from, I'm going to shake this thing like Jake, look, it works, derive from ecosystems. So, how will vegetation change as that effective 100th meridian changes? Are we going to have a lot less oak trees to appreciate in the future? Land impacts and interactions, with flooding especially, and even with droughts, how is that going to affect pests and invasive vegetative species, and so on and so forth, and even recreation, how we connect and commune with nature. How are those things going to change in the future as we have dying oak forests from the 100th meridian now eastward in Texas? And I think I'm going to hand it back over to Jay now, who knows a lot more about water than I do.
And I'll be the new Michael on this slide. But actually, staying back here for a second, I would put forth that what's going to be so important is being able to place value on these services that for the longest time have gone underappreciated, and the role they have in our economy. The loss of things such as what value do you put on a tree? And in the last drought in 2011, the state lost 301 million trees. And if you put them only a modest value on that, which is a hard thing to do, to actually determine the value, it turns out that those costs far exceeded anything to do with livestock loss or agricultural loss, which is typically the way that drought have been estimated to impact our economy, for example. So it's really important to be able to place value on these things using economics. And in water, I think we talked a lot about this, but we'll go through it for a little bit so far. The demands and the different sources where we get our water from and different sources for where the demand comes from, where the water is it groundwater, is it surface water, water quality. One of those connections with urbanization is they're intimately linked, water quality, water quantity, and urbanization. As we develop a landscape and introduce impervious cover, we're basically stripping away the natural filtration capacity of the landscape. So that is going to be a really important nexus to understand. And as Rich was talking about, conservation, reuse of water, why can't we make more use of gray water, right? Why do we have such a one pass through? In short, why are we going to the bathroom in water that's of such high quality we could drink it? Do we really need to do that? There's so many gains to be made in terms of reuse and conservation. And I won't belabor that much more, except to talk about social impacts of infrastructure. If we're going to change the way we develop a landscape, we also have to take into account social equity and actually social response. Different demographics, different cultures actually respond to the potential for example, building green stormwater infrastructure to mitigate against flooding. There's a lot of these are people and homes and properties opting in, following incentives offered by municipalities for developing new and innovative ways for infrastructure. We could do all the engineering and all the science we want on developing those, but if it's not going to be something that's going to be acceptable to people of all cultures or economic background, socioeconomic background, it's probably not going to work too well. And I've said quite a bit about droughts and floods already. One big thing that we feel is a unique aspect of the university is the Texas Advanced Computing Center. Another is all the great faculty we have and all of these different colleges and departments. That was a big thing about the Bridging Barriers Initiative is we had to make the case, why Texas? Why would this project be best done at the University of Texas? You took this project and put it in at Ohio State University, is the Vice President for Research's great example. Why would it not work as well? What's so great about Texas? This is one of the things that's great about Texas is the Texas Advanced Computing Center, which we have this building to thank for all the associated computer science infrastructure that we have. It's funded by NSF, largest academic supercomputer in the world, at least until the next really big one is built, but then UT comes back and regains the lead. And this is going to be important, as we'll see in a later diagram, that taking data from all these different disciplines is a real challenge, right? If we're going to have social scientists, engineers, natural scientists, geoscientists, et cetera, all collecting data on different spatial scales, different time coordinates, different values in terms of what's being collected, how can we actually wrangle all of that? I'm trying to use the acronym. Every computer and everything in this department, if you spend time here, has that Western theme, and I get really confused. But if we're going to try to wrangle all of that data and make it work together on one platform, that's a very significant challenge, and we're fortunate to have TAC persons on board, including Suzanne Pierce that Rich introduced to you as part of our team. All right, so I'm going to turn it over to Heather Hauser, Department of English, and one of the big winners in last week's Sustainability Showdown. Don't know what that is? Well, she'll be happy to explain it to you.
Oh, I'll probably spare you all of that. But it was fun. These were my competitors. They're now my teammates. But so
She squashed us.
it was a smackdown. So as Jay and Rich have mentioned, this is a very multidisciplinary project, and the data platform, the models, is actually one place where those disciplines have to interact. So our goal here is to produce in the future a healthy, safe, just, and economically vibrant Texas. Well, how do we do that? We have to marshal the expertise and the forms of data and knowledge that we generate in a variety of disciplines. And these are just, I guess, let's see if this works. These are just some of the domains, not necessarily the disciplines themselves, but some of the domains of expertise that we're drawing upon and trying to get to speak to each other. So, I mean, bridging barriers, it's an unfortunate metaphor, but the idea behind it is that we're bridging the gaps between, say, this building and my building way over in the six-pack, that there's knowledge produced in both of these places that we might not think of speaking to each other, but in fact they do. And that speaking to each other can actually not only lead to us reaching this goal, but actually improve our own research agendas as well. So this diagram, actually I can go to a bigger image of it so that you can see the bubbles. So what we're trying to get out, these are the conditions that Jay introduced, of population and climate change being the key stressors we're trying to address so that we don't end up in, what was our preferred word? The epic, the catastrophic, the apocalyptic scenarios that were in some of those maps. So these are the conditions that we are trying to respond to. And the ways that we're doing this, as Jay also mentioned, we have this data platform and modeling that will produce some future scenario projections so that we can respond to some of these stressors and the impacts. But in order to make this meaningful and actually allow us to develop strategies, we need input from all of these different domains. So one of the first things that we're focused on is data collection and management. So what are some of the existing conditions in the environment? For example, how much water, one of our projects is like, how much water is in Texas? We don't even know that level of information. But we also are getting input from the humanities and how people talk about the environmental conditions of the past, the present, and how they imagine different futures. We're also thinking about incorporating, as I think Rich mentioned, knowledge about past societies, in particular how past societies that responded to stresses actually either were resilient or were not resilient, thinking about collapse and adaptation. And so all of these things are feeding into our data collection and integration process to inform the model, but then it's iterative, so it heads back out so we can think about societal decisions, so we can think about the current environment, and all of that feeds back into this modeling process. So there are lots of arrows, I know, it's hard to maybe follow, but the key point behind all of those arrows is that we want this integration of knowledge and data from a number of disciplines, and then also for it to feed back out into our decision-making, scenario building, strategy building, and then it all feeds back in again. So that this, it's not as if you build a model, it runs once, and it's like, hey, we now have all the answers, but that we're continually revising and updating and refining our models and scenarios. So what I'm actually here, that was also me being Michael. I don't have a goatee, so it's harder for me to pass. But I'm actually here as one of the representatives of the Humanities and Arts and Communication component of Planet Texas 2050. I'm glad, actually, I forget who mentioned, I guess it was Jay mentioned the loss of 300 million trees. But this is the point I wanted to make about the role of the arts and humanities is like, yes, these are communication devices, but they're also providing integral forms of inquiry on the front end of this process. So for example, when we are thinking about the use of different uses of energy, how people respond to, say, adapting to a solar regime versus a fossil fuel regime. What are the impacts? What are the narratives? What are the relationships to those forms of energy across different populations in Texas over time, so that we know how people might respond? Like, we can have great ideas informed by our data collection and our modeling, but how are people actually going to react to some of the proposals that we might put forward, some of the strategies that we might devise? And things like history, cultural geography, archaeology in the case of Adam Rabinowitz, different forms of literature and art, those are the disciplines in which people ask, how do people make meaning across different populations, across different spans of time, make meaning out of their environment and different environmental challenges. So we think of the arts and humanities as like the domain in which we can develop kinds of inquiry about the real lived experience of some of the challenges and some of the opportunities that we're pursuing in Planet Texas 2050. And so what I have here are these two art projects. This actually isn't affiliated with Planet Texas 2050, but it is responding to the historic drought of 2011. This is a UT art professor. And this was a sculpture installation in Town Lake following the drought, or during it actually. But this was designed to represent those 300 million trees lost and like sort of give us a visual reminder of what we might in our day-to-day lives not really take account of as one of the effects of the drought, especially in an urban environment where our relationships to trees, I mean, maybe they're quite aesthetic, but they might not be as immediate as in other parts of the state. And this is actually a representation of a related project. So we have commissioned, brought on board an artist named Marie Lorenz, who does these tours of water infrastructure and gray water, actually like wastewater systems. One is in New York, and she's going to be doing one in Central Texas, going out to the Gulf to really put people in environments they might not have a direct relationship to, or maybe only the more aesthetically pleasing form of waterways, but to think about the entire system, collect their narratives, and do some community engagement around those projects. So to make people really understand what kind of water infrastructure, what kind of water relations they have, and then how those are impacted by things like flash floods or extreme droughts. So these are some of the ways, even though we might not think of something like a participatory art project as data collection, it also is like gathering these narratives, gathering these stories of how people understand their environmental relationships and how those get transformed under these stresses that we've been talking about. And so I just wanted to, this is a little bit, I wanted to do something maybe more topical. I'm not sure if people are familiar, oops, sorry, I keep doing that, with the energy humanities. Has anyone in here heard of that term before? Okay, I thought that might be the case. I'm like, it's the energy symposium, and yet people might not have ever heard of something. It's a pretty new field within my domain of the humanities, but what it's interested in is how the use of fossil fuels is really definitive of modern societies, right? And probably maybe no place more than Texas. This is an image from the film Giant, like the epitome of the Texas oil narrative. But looking at how, and this is a quote from this one book over here, yes, Energy Humanities. We are citizens and subjects of fossil fuels through and through. So how do we understand ourselves as citizens of fossil fuel, as having like an energy subjectivity? You know, we are subjects. Most of our daily lives is shaped by our relationship to energy, and especially fossil fuel extraction. So just understanding the human relationships, the representations of that relationship with energy, which is another dimension of the Planet Texas project that we want to really draw from and imagine, like, what are the existing stories we tell about our relationship to energy, and what might be other ones we could tell if we're thinking about different energy futures. So that's just a little taste of this sort of arts and humanities component of the Planet Texas project. And we just wanted to, I pause here, I actually hesitated to show this middle image because this is actually coming out of a center at Rice University. So if you go look this up, you know, don't cast aspersions on me. So what's happening? We just wanted to end before questions with a recent timeline of where we're headed. So this semester has been spent a lot on our bylaws, governance, how we are going to develop procedures and metrics for ensuring our success, for monitoring what we're doing. We're also beginning some of our communication, outreach, endeavors. I mean, this is actually sort of an example of that. We have coming up various kinds of listening tours. So we think of this as a research incubation period, so finding out what data is already out there, but also what people might, other government organizations, nonprofits, what they might need that we can also provide. So a sort of reciprocal relationship, and also a community engagement component. You know, we don't want to be operating on this campus without awareness of what other people's concerns are and how we can sort of meet people where they are with their needs and their concerns. And then we're beginning the setting up the data infrastructure platform. I mean, that will go on for this whole decade, of course, but getting some of that infrastructure and personnel in place. And same with these research projects we've been mentioning. And some of you I know in the room were participants in the first, which will be the first of several, graduate seminars to really get the graduate student population involved in research projects, some ideas coming from them, and also getting them involved in the existing projects. So that's where we stand now. And of course, we want to have very tangible things come out of this: research tools, understanding of complex systems, educational instruments, and all with this goal of achieving a resilient Texas, but also the knowledge that we build here being applicable to other communities as well. So here is just some information on how to get in touch with us, and unless you guys had anything to add, we can turn to questions.
Sure.
Thank you for that initial discussion. So we're open
If you have
to...
any questions, just send them to Michael.
Yeah, so we're going to email
Right
Michael
now,
Young
actually,
afterwards.
see if he responds.
And anybody have any questions? And if you have a question, please wait for a microphone so we can record it. It's obvious, it's all easy. You know how you're going to do this.
Hi, just two quick points. One is a high-speed train. I imagine it could be very useful for infrastructure and some high-speed train.
Yeah.
And connecting not just locally, but connecting, say, here to Dallas, to Houston. I know it's been under proposal. I just don't quite understand the political opposition against it. Secondly, just layer approach to electricity charge. The more you use, the higher the rate. So in a way, it reduces the incentive for people to abuse, electricity usage. Just quick comments from you guys would be appreciated.
You're talking about rate or economic controls on use of energy.
Right.
Could apply to water as well. Water,
Right.
I think, is even more
Right.
undervalued now on the markets. Regarding transportation, I think Rich is probably our resident expert on that.
Refer that one to Catherine. So the numbers I've seen, there's a convenience, obviously, to having these high-speed trains. It's not going to affect transportation problems in any of the cities that the train serves. So and that's generally true most places where there's high-speed trains.
Well, my understanding
It's not going to unclog MOPAC, and it's not going to unclog Interstate 35. It's going to be a convenience for people that want to ride the train from here to San Antonio or here to Houston. There's just not enough people that travel between those cities each day by car. It's going to affect local transportation.
Right, that's true. I just imagine if you look at all the major cities in Asia or in Europe, I cannot think of not one city that don't have such public transportation. And for Planet Texas 2050, I cannot imagine a solution without high-speed train. I just don't see alternative.
Can I just jump on something else you said? So we've thought one of the things that we are looking to do, a person to bring on board in the future is someone who does think about behavioral economics and environmental economics, and someone with that economic, what are the incentives, disincentives, what are the trade-offs? But just to the, why don't we have a high-speed train, regardless, the political issue, that is something also some researchers who have wanted to be involved with Planet Texas, just thinking about not telling people what to do, but how do things become political? What are some of the forces that lead to one issue becoming really politically contentious in a certain place, and in another place, and another issue it's not? So, that's not a given, right? It's something that's different in different conditions that can be studied and responded to potentially.
I just had a question about what your thoughts are about different land allocation strategies for like biodiversity conservation, so land sparing versus land sharing. I know you mentioned green spaces. I don't know. What are your thoughts about that, or do you have anything to say about that? Better strategy?
Well, I think that's part and parcel of what will go into the modeling. So this integrated modeling will not just model climate. It'll model how climate change cascades into the water sector, how that cascades into the urbanization sector, because urbanization needs to be modeled as well. So it has to be really dynamic and integrated. And I think once that's developed, then I think the real power of that will be able to make it accessible to people who make these sorts of decisions, right? If we do this right, and we're just talking about how to get people on board because we need the modeling expertise, to integrate those models is not a simple task at all. But ultimately, if you had that as a way to say, okay, if we made these decisions about how land will be used, it has to be taken into account with how are we going to find places for twice as many people to live. And that is not easy at all, but we think having these simulations rooted in an understanding of how the modern environmental system is working through these monitoring and analytical studies is going to be the way to go. I don't think there's any easy answer to how are we going to preserve our ecosystems and at the same time host twice as many people. Yeah. A really good question. Thank you.
You go ahead. Go ahead.
Sorry, now a little distracted. I appreciated your comment on wanting to include somebody on the economic side and the environmental services modeling. I was just curious about the funding framework for the entire initiative. How does that work? What do you got to run with?
So trust fund kids and
Yeah, so the Vice President of Research is seeding this with the intent that we will triple to quadruple the money that the Vice President of Research puts into the initiative over a decade period. So the TOC, the Theme Organizing Committee, one of our big jobs is to look for opportunities to leverage the Vice President's money to bring more money into the university. And so whenever we have meetings, we have monthly meetings now. We used to have weekly meetings, it's twice a week meetings, but a lot of effort's been put into looking, over the next year at potential opportunities at the federal level, as well as philanthropy and other sources of funding. So that's probably one of the top items on the Theme Organizing Committee's list in terms of what we're trying to accomplish.
Right, Heather talked about, what we've been doing this spring semester is how we govern ourselves, how we make policy and procedures for how we disperse the internal funds that we do have. Now what's really ramping up is as we start to research, we really have an eye towards how can we, as Rich said, sort of collect seed data because we have enough money to just get in trouble from the Vice President for Research. And the idea is how can we collect seed data to show results and innovation to then turn around and go to federal agencies for larger funds. And we're also looking for, the university development team is working closely with us. So going to corporations and foundations. And all of a sudden, I never had as many meetings dropped on my calendar without my knowledge until Planet Texas happened. And I open up my Outlook in the morning and PT 2050. It's like, oh, I didn't know I had 3 meetings today. And it's, if we have to get together and integrate, right? To take 8 people from different disciplines. I make fun of that, but it's also a necessary part of us getting to know each other and talk each other's language. But what's now starting to ramp up is making visits to Rich and I and Michael. Week after next, we're going to be going to Houston, and next week we're going to be in North Austin meeting with various companies that may have a vested interest in what we're planning. So while that's a very exciting part of it, it's also a time sink part of it. So we're wearing many different hats now in this project and figuring out how do we govern ourselves, how do we raise funds externally, how do we raise funds in a development context, and oh yeah, by the way, we have to do this research too. It's a lot.
And I'll add that the industry we've spoken with thus far is extraordinarily interested in this initiative. I mean, they know that what happens to Texas in the next 30 years is going to affect the bottom line for them. whether it be workforce or the availability of water or the availability of energy. So, there's a big economic issue that we're dealing with as well. And we have talked a lot about having to bring an economist on board with everything we do, and we haven't done that yet.
Joe.
Heather, I just want to digress for a minute about the politics of high-speed rail. You're too young to remember, but in the 80s there was a serious attempt to build this stuff. And it was one of the principal organizations that was against this was Southwest Airlines and road building firms. So,
And even in California, I used to live in the Bay Area, and there was a big fight against high-speed rail in the place you would think people would love it, but it was a NIMBYism, like, oh, it's going to go through the rich neighborhoods of Silicon Valley, and I don't want that in my backyard. So, yeah, there are problems from all angles, really.
well, anyway, I was listening to all your comments. It sounds like a lot of the problems is full cost accounting. If we are getting Alzheimer's from our freeways, that's not being factored into the cost or the price of things. Do you anticipate that this will be among some of the major recommendations that come out of PT 2050 is a better accounting system for our environmental services that we get?
Valuing the real costs
Right.
of these changes, that has to be, I think that's what's going to drive policy change. Yeah. I think we're going to be.
And we need the accounting firms on the listening tour then.
Well, so, yeah, Joel Youngblood, who's a development specialist, University of Texas at Austin. So he just came up with a new idea.
Yeah, so I'm an engineer, so I do cost-benefit analyses and have done national cost-benefit analyses for changes we could make to building stock and the benefit that populations would get from reduced exposure to air pollution, do those kinds of things routinely. And I think we do need to do cost-benefit or benefit-cost analyses for almost all of the scenarios that we project in the future. Because what we're going to be saying is, this is what happens if we do nothing. And if we do X, Y, Z, A, B, C, D, E, F, these are what we predict, with some uncertainty, obviously, will happen in the future. And there needs to be a benefit-cost analysis for all of those scenarios.
How do you translate?
I can only speak to the building side of things, so I'll let Jay deal with the water. From the building side of things, it's usually an energy cost, it's an energy penalty, and the benefits are usually health-related. So, or cost of materials or cost of, advanced filtration. So in the world that I work in, it's pretty easy to put dollars to things. It's harder when we're dealing with trees that are dying, right?
The spiritual, there are some people who do work on natural capital or ecosystem services and think about those spiritual and aesthetic and also just life ways, which we might think of as occupation, like what is the labor you do to make money in relation to the land. But there's also just the ways you live your life that are tied to the land that get, or water, or whatever it might be, that get disturbed. And so how do you account for those things that are even harder, as you're saying, like what price would we put on a tree, but what price would you put on like some group's spiritual relationship to a body of water, right? So there are, that's a very complex question that I know some groups, other universities working on, but certainly something relevant here too.
That field is, I think, really in its infancy, and that question of what's a tree worth? What does it provide us? You think of all the ecosystem services that it provides, from food, habitat, so carbon sequestration, water filtration, aesthetics. It's just, you just go on and on. It's just remarkable. And then, okay, what value do you put on a tree? I talked to environmental economists in the 2011 drought when they came out with this number, 300 million trees, to try to estimate it. And it's a very nascent field. But there are some ways you could do it. When the Dell Medical School was put in, they had to move some live oak trees. That was a cost of $45,000 per tree. So maybe that's a high-end estimate. I went to Home Depot. What's the cheapest tree I could find? It was this really miserable little thing that was about to be, sent out of inventory and thrown out. It was $19.95. So there's a range. What do you pick in the middle? If you look at studies of how the resale values of homes change in a city like Portland, with every new tree that's added to your property or existing tree, it's about $5,000 per tree. So just take 5,000 and multiply it by 301 million trees lost. And all of a sudden, you're at a number that's so much larger than the big 3-inch headlines in the Austin American-Statesman in the 2011 drought that the state was losing $8.7 billion from agricultural and livestock losses. So that shows how important it is to do this to do this accounting, but it's just not simple. There's no Excel spreadsheet you could just pull up that.
I do think it reflects how complex all of this is, but I think this question of what's the value of a tree would be a great project for a course, right? That's a question you ask students and have them dissect what a tree gives us and how much it's all worth. That would be a wonderful problem for a class.
So I assume, many states and regions are going to be experiencing these same problems, population growth, climate change and all that. Do you guys know other states like California, New York, or whatever that have similar initiatives happening at universities there?
I don't know for sure. I'm sure there are something like this. I'm not sure there's any specifically as focused as this one. And one of our things we put forth in the proposal was that Texas is in a lot of ways a sentinel community, that the changes that are happening here are going to happen fast and big, and that therefore whatever we perhaps can discover will be very transferable to studies in those other regions, right? In a way we get the best and worst of all worlds, right? We've got the arid Southwest U.S. climate and that drought proneness. We're also sitting right on the Gulf Coast in this warm body of ocean water that's fueling hurricanes. Now, if you look at the projected economic costs of climate change forward into this century, the Gulf Coast gets hit hard and the Southwest U.S. gets hit hard, and Texas sits right between the two of them. So we really feel what we learn here may help other regions. Yeah. Thanks for that question.
Yeah, nothing quite like this, especially I think the modeling component, but there are some other grand research challenges out there, like Arizona State has something focused on the desert scenarios that might be applicable around the globe with other desert-based ecosystems, but and UCLA has one that's focused very much on LA, but nothing quite with this modeling integrated data component in this kind of like a state with this variety of bioregions and other challenges.
Since you mentioned UCLA, a lot of the research on health effects of freeway communities is coming out of UCLA. It's 1.2 million people, 1.2 million in the city of Los Angeles that live within 100 meters of a major freeway. And that's where a lot of the health effects results are coming from there and the Northeast.
I lived in Los Angeles for 4 years. I'm trying to think, is there any place that's not within 100 meters of the freeway?
Thank you for the presentation. You show in one slide all the different things that are going to be included in this mega project of research, and from energy to urbanization, transportation, health. So I would like to maybe ask a comment from you. What do you think would be the most important area of research? What would be the priority if you could choose one of them?
My area.
Yeah, right. That's when we become competitors again instead of teammates.
Yeah, that was facetious. I think the very interlinked nature that that the feedbacks between these systems, the nexus between them, I think really dictates that we can't point to one thing and say, oh, if we figure water out, then we'll have it licked, right? I don't think we can separate one. They're so interdependent on each other. And that's been, I think, one of the real challenges of this grand challenge, is trying to draw enough of a box around it that we can actually focus and accomplish some meaningful research. And that's, from the get-go, we were much wider. And we've gotten narrower. And our external review committee helped us with that a bit too. Yeah.
I was going to add, there's another issue we haven't talked about, which is unintended consequences of taking action to try to make Texas's future a better future, right? So an example of that relates to water, is that all over the United States now, right, there's this move to conserve water in buildings by putting in low-flow water faucets, low-flow devices in buildings. When you do that, and we know this to be the case now because of some horrific unintended consequences, if you're not flushing out the pipes enough, you grow biofilms on the inside of premise plumbing, and that biofilm can be chock full with Legionella pneumophila, right? And so when you turn on the tap and you get aerosolization of water, whether it be your shower or a sink, you basically now have the potential for more Legionnaire's disease breaking out, and we're seeing that in the United States. So Johns Hopkins University, in their hospital, put low-flow water devices in throughout the hospital, and about a year after they did, they went in and took them all out because of concerns of Legionnaire's disease spreading in the hospitals with people that have compromised immune systems. So that's just one example of many examples of trying to do the right thing and then having this negative consequence that comes from it. And one of the things we need to learn in this whole process is what are those unintended consequences and how do we fix them so we can do the right thing and not make people sick in the process, right? So nobody, as far as I know, in the United States right now is working on solutions in buildings where you can actually have low-flow devices and perhaps have an on-site treatment system, a small packaged unit for large buildings where you can actually treat the water and make sure you don't get those kinds of biofilms building up. Another example is turning down the temperature in water heaters. That promotes Legionella biofilms in water heaters, and we're seeing that in the United States as well. In fact, other countries have gone in the opposite direction now. They're saying, we've reduced the temperatures of water heaters, we need to drive it back up because we're seeing too many outbreaks of Legionnaire's disease. Comes from that as well. So there are these connections and unintended consequences that we need to deal with as we move forward. Otherwise, we may think we're doing the right thing and end up not doing the right thing.
You've mentioned several times the 100-meter effect from freeways, but was there any indication of how far the negative impact of a freeway goes? Yes. Presumably a kilometer is better than 101 meters.
Yeah, so the cutoffs are usually 200 to 300 meters. Once you get beyond about 300 meters from major roadways, highways, or freeways, you get to sort of a background condition where the health consequences are significantly reduced. So that's the answer. So there's always a control, and the control is always certain distances away from the interstate. We have this great opportunity right now, and this is something we're doing this summer as part of Planet Texas 2050. Google, working with the Environmental Defense Fund, has put together 2 Google neighborhood vehicles. The vehicles you see driving down the street and doing images of streets have been equipped with about $200,000 each of air pollution monitoring equipment. Those vehicles have been made available to us for the next 3 months. So starting next week, we're going to be doing a bunch with Josh Apte, who some of you might have heard of at the university. Josh's team is going to be doing, driving gradients from Interstate 35, MOPAC 183, so he'll get really good pollution measurements with gradients away from all of the major roadways and freeways in Austin. Now, we want to do this eventually for the entire, all the cities in Texas, at least the major cities in Texas. But we have them available now to do Austin. So we're going to be characterizing the heck out of gradients in transportation-related air pollution from major roadways and freeways in Austin this summer. So we're getting a big kickstart on collecting a lot of measurements related to air pollution in Austin for the summer period. So that'll be great for us.
So mine was in part a comment just in juxtaposition in time. We were talking about valuing externalities and things, and I just wanted to mention the city of Austin, the city council today passed a resolution recommending carbon pricing and carbon fee and dividend, and we are now the 3rd largest municipality in the U.S. to have passed and recommended that change.
That's great to hear, and I think that underscores that I think a lot of potential progress will be made at the level of municipalities to institute measures like that, because I think my opinion and my experience at the state legislature, that is not going to be, we're not going to be able to move the needle as rapidly.
But Austin then becomes a model. So as this moves forward, we can see what happens in Austin, and we can project based on what happens in Austin, what might happen in other cities in the future. So it's valuable for us to have that information and to collect that information over the next several years.
All right. Nothing else? All right, I think we'll close it right there. Thank you very much, Jay,
Thank you.
Rich, and Heather. Thank you. Great job.